Today's problem is distribute candies. Difficulty is hard. Uh, I've seen a lot of problems, about distributing candies with, different rules and constraints and things. I've never seen this one. You are given the root of a binary tree with n nodes, where each node contains a certain number of candies, and the total number of candies across all nodes is n. In one move, you can select any two adjacent nodes and transfer one candy from one node to the other, either between a parent and a child. This transfer can occur between a parent and child in either direction. Task is to determine the minimum number of moves required to ensure that every node in the tree has exactly one candy. Test cases are framed such that it is always possible to achieve a configuration in which every node has exactly one candy after some moves. Okay. The method for doing this, I think, is easy enough to describe. I think we would want to do it as a post-order traversal. Let's see. So from here, we'll go to the left subtree. Now we want to. If we're going to do a post-order traversal, we're going to start with the leaf nodes. Okay. Now, if the leaf node doesn't have a candy, then we'll just pull a candy down from the parent. Here we can actually. Let me get a pen here. Okay, and then we can leave that there for now. Okay, so this node here will pull a candy down. That's one move. Now, post-order traversal, we would go to the right subtree, and then from here we would go to the left subtree. Now we're at a leaf node. That doesn't have any candies, so we got to pull a candy down. Well, but this doesn't have a candy either. So we pull a candy down from the parent and then pull the candy down again. That's two more moves. So now we're at 3. Same method for this node here. We have to pull a candy down from the root to the parent node to this node. That's 2 more. So that is 5. All right, post-order traversal. And we are going to go, now we're at this node. That doesn't have a candy, so we'll pull one more down from the root. So that's a total of 6 moves. Okay. Let's look at the next example, because that works actually in the other direction. So post-order traversal on this. We'll start here and go to the left subtree. That is here. That's 0. So we'll pull one candy down from the root. Continue with the right subtree. So we're at this node, and then from there we'll go to the left subtree. This has too many candies, so we've got to push them up. So we'll push 2 candies up, one at a time, from here to this node, to the parent node. So that gives us a total of 3 moves, right? Okay, continue the post-order traversal. We are at this node, the left subtree. That doesn't have any candy, so we pull 1 down from the parent, which we can do because the parent has 2. We push 2 up from the 3 to the parent node of the 3, and now we'll pull 1 down to this node. So it's a total of 4 moves. The root is already taken care of because we pulled 1 candy from there into the left subtree. Okay, total of 4. All right. This works because, once we've once we've processed a node, we're done with it. We don't have to think about it anymore. Now, the solution here, the implementation, is we're going to do a recursive implementation. I mean, I guess you could do an iterative implementation, you know, of a post-order traversal with a stack, but iterative solutions for trees just seems more intuitive to me. So let's actually get rid of that for now. All right, let's see how this would work. The main method is very simple. We have a class variable, answer. We'll set it to 0, and then we'll call the recursive method, and we'll pass in the root. Whatever comes back from that is what we're going to return. So, okay, so the root comes in. Is the root equal to null? No. All right, well then let's process the left subtree. All right, so that would be this node here. So recursive call, left subtree, that left subtree comes in, the 0 node. We will process the left subtree of the 0 node. Well, that's null. So we do the recursive call, but because it's null, it returns 0. Same thing with the right subtree. That also returns 0. So answer, and we should write the answer here somewhere. Answer is initialized to 0. Answer plus equals absolute value of the left plus absolute value of the right, which both of those were 0. Return root data 0 plus 0 plus 0 minus 1. So what gets returned back up here is -1. -1. That's what gets returned from the left subtree. And what that means is we are one candy short down here. Okay? So we finished processing the left subtree of the root. So now we'll process the right subtree of the root. That is this node. We'll do the recursive call on that, and we will process the left subtree of that node. So that is this. Now, what's going to happen here is the same thing that happened with this node, and that is left subtree is 0, right subtree is 0. It doesn't change anything about the answer, but it does return a -1, meaning, again, we're a candy short. Now, after processing the left subtree, process the right subtree of this middle node here. The right subtree, same thing is going to happen. It does nothing to answer because the left subtree and right subtree of the leaf node are both null. But it does return 0 plus 0 plus 0 minus 1. It does return a -1 up here. Okay, meaning we're one candy short. All right, so now returning to this node, we've processed the left subtree and the right subtree, and they're both -1. So answer plus equals absolute value of left, which is 1, plus absolute value of right, which is also 1. So answer is now 2. And we're going to return from that node the root data, which is 0, plus left, which is -1, plus right, which is -1, minus 1, which is -3. So what comes back up here is -3. And what that means is in the right subtree, we are 3 candies short. Okay? So now we've processed the left and the right subtree for the root. And we can go ahead with this. Answer plus equals absolute value of left, which is 1, plus absolute value of right, which is 3. So we add 1, we add 3. Now we've got 6. Now it really doesn't matter what we return here, because we don't do anything with the return value of this call. We just return answer. So answer in this case is 6. Okay, let's do the other one as well, because it's a little bit different process. Well, I mean, a little. It's different in that there's too many candies in the leave node. So, all right, passing in the root left subtree. Well, this is going to go the same way here. This is not going to affect the answer because the left and right subtree of this are both 0, but we're going to return 0 plus 0 plus 0 minus 1. So it is going to return -1 up here, which again means we're a candy short in this subtree. All right, now processing the right subtree here, and then recursive call, we would process the left subtree. All right, so that comes in. Left subtree of the 3 is 0. Right subtree is 0. Answer, oh yeah, got to write answer here. Answer, again, is initialized to 0. So let's see, answer, we're just adding 0, so that does nothing. Return, root data, 3 plus 0 plus 0 minus 1. So that is going to return 2 right here. And that means we've got 2 candies too many down here. All right, now processing the right subtree of this node. Left subtree 0, right subtree 0. It doesn't affect the answer, and what we return is -1. We are 1 candy short. All right, so now we can finish processing this node because we have the left and the right subtree. So answer plus equals absolute value of left, which is 2, plus absolute value of right, which is 1. And so answer goes to 3. And we return the root data, which is 0, plus the left, so that's 2, plus right, which is -1. So now we're back to 1. Minus 1 is 0. Did I do that right? Root data, 0, plus 2, minus 1, minus 1. Okay, that is right. That returns 0. That says we have exactly the right number of candies in this subtree. You know, they may not additionally be in the right place, but we do have the right number. All right, so now we can finish processing the root. We have the left, we have the right. Answer plus equals absolute value of left, which is 1. Absolute value of right is 0, so answer becomes 4. We return something, but it doesn't matter what it is because what we really care about is answer, which is 4. All right, let's try and run this. Yeah, actually, let me move this out of the way here and run it. It's not a good place for it either. Just move it up here. Okay. Okay. Trying to think if there's anything else to say about this. So it's really a excuse me, a post-order traversal where each node tells its parent node how many candies how many candies is it off from what it should be. You know, it might have too many, might not have enough, but in any case, it either returns and says, I'm short this many candies, or I have this many candies too many, or I have exactly the right number of candies. And so that is why in this case, we're using absolute values for the answer, because it doesn't matter if nodes have too many candies or not enough candies. A candy is going to have to be moved in either case. So that's it. Please like the video, and you can subscribe to the channel, and we will see you next time.